Hi, my name is Robert Doyle, and I would like to introduce you to Chapter 1 of our Cisco 2 Academy here at Dona Community College, Introduction to Switched Networks. Chapter 1, we will have an introduction, we will cover LAN design, and we will do switched environments, and then we will finally have a summary. Our objectives for this chapter: upon completion of this chapter, you will be able to describe the convergence of data, voice, and video content on the switch network, describe how switch networks work on a small to medium business, and explain the purpose of frame forwarding on a switch network. You will also be comparing collision domains and broadcast domains. Remember that collision domains are primarily switch based and broadcast domains are primarily router based. Okay, with the growth of the internet and computer networks, you will see different types of technology. Here we have a router that you would see at your home. Here's a stack set that you would actually put inside of a rack mounted system. Here's the back of the rack mounted system where you have the video, and then here's your telephones that you probably see more and more Cisco based. When you're at a job site, you may hear the term U1, U2, U2, U3, U4. What that means is whenever you put equipment into a rack, U1 is going to be one of these units right here. If you're installing a U2 system, it'll be two of these as height. U3 would be three of them in the height. U4 would be four of them. So each U that you hear is going to be each one of these units doubled. The convergence of technology and engineering. As you know, we have IP phones, email, we have video, Skype, everything of that nature, and it just so happens that it's getting to the point to where the internet cannot handle the traffic. So they're having to find a way to combine all of these together and have them go all down one funnel, and we all get the information, hopefully, all in one piece. You have multiple types of traffic type things. You can do voice over internet, which is your voice on a telephone system. It has a lower priority than, say, video or email because you don't need to have it as accurate as the other types of forms of video that you have, or actually forms of computer media. We have borderless switch security. We have borderless switch networks, which are networks that anybody can access anytime, anywhere, seamlessly. So when you're at the community college, you can get on the wireless network, you can plug a cable in, you can get on the cable network, you can watch videos, you can hook up your iPad. So basically, borderless just means that you have the capability of accessing everything, anywhere, every place, anywhere you're at. The hierarchy of a borderless type network, we have two types. We have a 3-tier and we have a 2-tier. The 3-tier consists of the core, which is basically your IP provider, and then you have your distribution, which would be like NMSU, and then you have your access, which are your classrooms. They also have a 2-tiered LAN design, which is they combine both NMSU and Comcast together, and then down here is your access at your classroom level, office level, so forth. Hierarchy, it's modular and it's more flexible depending on which one you use. Here we have a core distribution access type model. The core is up here, distribution, and it just happens to be the core is going to be your primary building. So in this case, this would be NMSU. And then we have Dona Community College, College of Engineering, Carlsbad, Grants, and whatever. So everything comes out of a core system, and then it's going through distribution, and then it's allowed to be accessed by everybody in the organization. The role of switch networks is crucial to network design. You have to make sure that you are only sending the information that you need or the data that you need. A switch network is more flexible. and it allows for more traffic management and supports quality of service. And it's also used for wireless IP phones and access like that. So a switch network basically means you're using more switches within your environment to help manage your data from point A to point B, phone call from person to person, so forth. Here we have a switched form factor. And what this means is, like I mentioned before, this is the U1 unit. 2 of these would be a 2U unit. 3 of these would be a 3U unit. But each one of these is a fixed form factor because this only has 24 ports, this only has 48, and so forth. Here we are looking at kind of the same thing, but this is considered modular, which if you look at in each one of these, it has one of the U1s or U2s or U3s that I mentioned earlier, or 2Us. I get the. It's actually U1, U2, U3, not 1U. I got that backward, but I think you get the point. And here, if you notice on this unit, everything is sideways, so you can mount them vertical or horizontal depending on how you see it and it fits. This is called a stackable form, where you can take multiple smaller units and you can stack them using connecting cords to connect them together. On here, I guess the general concept would be that the switches keep the tables to determine the best traffic count for them. They use forward Ethernet frames based on the destination of the MAC address of the frame. So it's going to be hardware to hardware. What hardware is going where, and it uses your device's MAC address to determine where it's going to. Whereas on an internet type structure, it uses IP addressing, IP address, and then it goes to the switch concept that you see right here. Dynamically popular is switch tables. Is the tables create CAM tables, or content addressable memory, and it knows who's connected to what MAC address is available at the time. And the problem is you can get floods throughout CAM tables if you're not careful when you're actually creating them and hooking them up. Okay, here we have what's called the forwarding methods. Store and forward is the one that will, as the information comes into the switch, it will wait for all the information to show up. It will validate that it is correct, then it will send it forward. This is a little bit slower than what you would like, but it actually ensures that the information will be forwarded correctly in the text. Cut through, basically, as soon as the information comes into the switch and it knows where it goes, it's going to start sending the information, and it will wait for the remainder of the information to follow behind it. Not as reliable as store and forward, but it is faster. And there are some cases like video where you need it to be faster. And if you ever have watched a video on the internet, you'll see the picture be nice and clear, and it'll be kind of grainy, and then it will go back to nice and clear. It's because it's not getting all the data to maintain the string, but it's enough for you to see what's happening. Store and forward, like I mentioned before, it checks for errors via the check. It automatically performs, and it's slower in performance because it verifies that the information is correct. It checks it and forwards it. And this is just an example of the frame header, network header. Here's the checksum that verifies the information is correct, where it's going to, where it came from, the type of it, and preamble of what information is being sent. Cut through allows the switch to forward in about 10 microseconds. It doesn't check, it just forwards it as soon as it knows where it's going. Same thing here, little checksum, nothing major, where it's going, where it's coming from. Like I said, cut through switching is the fastest way of doing it, but if you're watching video or doing anything like that, you may see some pixelations, and that's why you get it now. If you had to wait for the forward and store, you would be waiting for long pauses to buffer them. And that's what happened in the old days when you were watching videos. You had to wait for it to buffer, then you would see the video and have to wait again because it was verifying content and quality. Collision domains are areas on the internet to where if you are transmitting and receiving at the same time and you're on the same collision domain, you would collide and you would lose information and data. A hub is a very bad collision domain because as the information comes into a hub, like say we're coming in at 100 megabits, and if you have 5 ports, each plug now is broken down into 100 megabits, and each port has to wait for the other port to stop transmitting before it can send its information. On a switch, every port is its own collision domain, and that's why a switch can transmit and receive at the same time, and whatever the primary speed of the switch is the speed of each port. Whereas a hub, if you have 100 megabits coming into a hub, and if you have 5 ports, each port is now only 100 megabits. It actually divides it. And that's why if you're ever working at an organization and if you find a hub, you want to replace that as fast as possible, because that is your bottleneck. That is where everything is slowing down. That is where you're having issues of speed. You can have the fastest internet coming into your organization, but if you have a hub anywhere in the organization, it will slow it down to the speed of the hub, and that is not a good thing. Broadcast domains are basically every internet website you go to is a broadcast domain. Switches create broadcast domains, so anything.com, anything you go to, and they use forward. All broadcast domains are all ports. Broadcast domains are also used for keeping track of IP addressing, subnets, everything of that nature. So broadcast domains, everything on the internet you basically go to is a broadcast domain in essence. And to help solve this, you can put in switching. You can switch everything to full duplex on a switch. You can create larger buffering so you can have more information go through. You can employ higher port rates and so forth. But the primary thing that I would recommend here is on a switch you can choose between full duplex and half duplex. The primary difference is when you choose a full duplex, you are transmitting and receiving the information back and forth at the same time, which is great. But if you're having network issues, switch your switches to half duplex, which means information would have to wait to go back and forth, back and forth. But if you think about it, it is a lot safer, or not safer, but it guarantees that a computer network will continue to run, granted slower, but it will run. If you keep it in full duplex, it will stop running because it cannot transmit and receive at the same time. And that's why you would always want to do that. So remember, if you have a switch that's going bad and you're not too sure exactly what it is, switch the switch to half duplex. You will lose speed, but you will keep connectivity, and then at a later time you can go in and resolve the problem and then put it back into full duplex once you're done finding the issue that happened. Also too, a lot of switches will automatically switch from full duplex to half duplex if they have issues on their own, and that way they protect themselves and it keeps your computer network up and running. That's why sometimes you will have very fast speeds and all of a sudden it will drop to very slow, but at least it's still running, and that's the key thing you need to worry about. Summary. Remember that with the internet nowadays, every device, your cell phone, tablet, computer, work phone, is handling voice, video, data transfer. And it also affects the way that businesses handle stuff. There are no physical boundaries when it comes to the borderless network. And the borderless network basically means that you'll be able to do everything anywhere you're at, anywhere you're at. Unfortunately, with the growth of the internet, everything is slowing down. So there is going to have to be a change in the way that information is sent, and that's going to be Internet 2.0 or whatever they're calling it now. Also, too, there's also a couple layers of hierarchy, 2-layer, 3-layer. If you're going to go distribution, core, access, then you also need to consideration how flexible do you want it to upgrade it, modular. Do you want to use store and forward or cut through? If you're a bank, I would definitely use store and forward because you want to make sure that all transactions are confirmed before they go through. If you are a videoing streamer, cut through is fine. You just need for them to get it as fast as possible. Then here, of course, is your high speed, full duplex, half duplex, like I mentioned before, about making sure. And then also to you need to make sure that you know the difference between your broadcast domains and your collision domains and what switch sides you need to have on it. So that's Chapter 1 of Cisco Academy 2 here at Dona Community College. Please let me know if you have any other questions, and thank you.